Hello and welcome. In today's video, we will continue our exploration of LLM and generative AI in Microsoft Fabric. Specifically, we will talk about and focus on how to implement Retrieval-Augmented Generation or RAG architecture that is enterprise grade. Let's take a look at this slide here and kind of get a little bit of a refresher of what we're trying to do. Now, this video is the third in a kind of series of me trying to get to the perfect RAG, and this video is going to be a little bit more detailed, a little bit more technical than the other two, because I will cover some of the things that I tried to avoid before. We're going to get a little bit more into configuration. So if you're really trying to understand how RAG works, why do we need it, what are the pieces that need to come together, and how do we pick different tools in Microsoft Stack in order to cobble together this RAG architecture, this video might be the best one. You don't have to watch the other two. I'm going to start from scratch. So if this is the first one that you found, that's fine. You're going to get everything you need right here. So let's talk about why do we need RAG and what does it do. So if you have been around kind of LLM Gen AI world, RAG comes up a lot. And the reason it does is because we have some inherent limitations with LLMs. So our LLMs, be it OpenAI or some other LLMs, they all have one limitation, and that is they are effectively read-only. Now, this video is focused on a kind of novice, beginner, so I will use very layman kind of vocabulary here, so I'm not going to be using super highfalutin terminology, so we're going to keep it simple. So for all intents and purposes, when you're looking at ChatGPT, when you're looking at all of those Gen AI LLM models, they are effectively read-only. Companies spend billions of dollars and months and gigawatts of electricity trying to train those models. They're feeding all those billions of data points into the model during the training, and when they're done, they expose that model to us so that we can use different type of interfaces to interact with them. What that means is that those models know a lot, but they don't know anything. Specifically, they don't know anything about things they did not learn on. So if you ask them about things they did not learn on, they will always provide an answer, but this answer is likely to be hallucination. This is something that they're going to interpolate or guess, or who knows how they come up with those answers. But very often you have very specific questions about information that's specific to your organization, your industry, the particular time in space, and because those models were trained months before, sometimes a year before, they have no clue about anything that's happening in your specific scenario. So what we're trying to do is we're trying to merge the two problems or the two opportunities. Opportunity number one is take that amazing technology and that amazing capabilities that LLM models, Gen AI, brings to the table, but then figure out how to employ those capabilities on your own data sets and do it in a secure way. So in our case, the data sets we're talking about are PDF documents. So we have these PDF documents that live in my environment, maybe on my network somewhere. And what I would like to do, I would like to be able to ask a question that's relevant to these documents that OpenAI does not know anything about, but somehow bring those two worlds together. And the way this works is the following. I need to do a little bit of pre-work. And what that means is I need to take all of my documents and I need to put them in a format that I can ask a question that is going to find information in the documents not based on keyword search. So God forbid I misspell anything, which will then impact my search. I want to be able to search by meaning. And that way of searching by meaning is provided by what's called a vector database. So if you watched a couple of my earlier videos, I've been experimenting with what that vector database might be. In the first one, I use AI Search, Azure AI Search. Then in the second one, I use Chroma DB. And finally, I'm landing on Cosmos DB, which I think might be the better option today. And we will talk about why this option might be better than the other two. But basically what we're going to do is we're going to take these documents, which are just binary PDF documents, and we're going to load it into this vector database. But in order for me to run my questions on top of the vector database, I need to convert these files from basically English text, from letters and words, into what's called embeddings. Embeddings are digital representation of, let's say, tokens or syllables inside of the word. So what happens, I take my documents, I convert them to embeddings, and I store them inside of my vector database. And then what happens, if I have a question, I take my question, I convert that into a vector, into embeddings, and then I can run embeddings on top of embeddings. Basically, I can query my vector database, and vector database is going to respond based on the meaning of the question, right? So it's not going to do an exact keyword search. It's going to try to understand what is it that I'm asking and what is it the closest matching text in my vector database that matches it. So let's say I loaded thousands of different documents into my vector database. Now what I can do is I can ask a question. The question comes into my vector database. Vector database does a search, finds a relevant information that is pertinent to the question that I asked, right? Because I might have gigabytes of different documents that I've loaded here, and only certain documents are actually relevant to what I'm asking. So I'm going to store all of the information in my vector database. I'm going to ask a question, find the relevant documents, and those documents could be enormous. I could have thousands of pages in those documents. So what I want to do is just find relative paragraphs, or relevant, rather, chunks of the documents, take that context, take that information, and pass that as part of my prompt into the LLM or OpenAI model. Now OpenAI will read the relevant information, because now in this prompt that I can pass to OpenAI, I can pass a lot of information, sometimes hundreds of pages, maybe even thousands of pages. So what I will do is I find the relevant chunks of the documents, I will pass it to the OpenAI model along with my question. And now OpenAI will take the relevant information from my company, it will take my question, read them both, think about it, and spit out the answer that I'm actually looking for. And that's how I bridge the two worlds. I use the power of OpenAI to quote-unquote reason, and I find a way, instead of passing terabytes and gigabytes or whatever it is I have of different corporate data into OpenAI in prompt, which is impossible, I find a way to find only relevant information and pass that in my prompt. So that's the problem that we're trying to solve with RAG. The question is, why are we using Cosmos DB versus Chroma DB, and why I was not happy with Azure AI Search. The challenge is that I'm trying to implement this in Microsoft Fabric. Microsoft Fabric is a PaaS technology, is a SaaS technology, software as a service, and then I was trying to find a way to implement my RAG architecture staying 100% in SaaS, not having to leave kind of SaaS, software as a service premises. And in the first video, I had to use document intelligence to process these documents, chunk them, and then I had to use another PaaS service, which is AI Search. And I was just not happy. I had to go back and forth between SaaS into PaaS, and I was like, okay, there's got to be a better way. So then what I did, I said, okay, instead of using Cosmos DB, let's use Chroma DB, which is an open source, it's cheap, or AI Search rather. It's cheap, why not use that? So I implemented that, and that worked really well. However, the problem is Chroma DB does not, while it's very functional and it does have all of the capabilities of a vector database, it does not give me the enterprise grade. Because ultimately what I'm trying to do is I'm trying to build a knowledge base, right? So I have all these documents, I'm going to have documents across multiple domains. I might have HR, I might have finance, I might have R&D, right? Marketing. So I have a lot of different domains, and I want to manage my knowledge base from a central sort of knowledge database, right? And Chroma DB, just the tooling around that product is not very sophisticated, is not very mature. So I was trying to figure out what might be a better way, and I was contacting my friends from Microsoft, said, hey, we're doing this super cool technology in Cosmos DB. We're bringing this super cool capability called DiskANN, and you should take a look at it. And I did, and I'm happy that I did. So the next question is, what is this DiskANN Cosmos DB stuff? So in order to get going on the journey, there is an article on Microsoft Learn that kind of walks you through this preview. And they talk about Cosmos DB, which is a mature product for NoSQL, which is pretty cool. We're not going to get too deep into Cosmos DB. We'll just cover it a little bit, just enough for you to get going. So here they cover how the vector store works. and they give you a link to enroll into the preview. So unfortunately, this is a little bit high level. It's not super useful to actually get going. I had to do quite a bit of research to be able to actually build a solution around it. So hopefully this plus the code that I will be sharing in this video later on our blog will be helpful for you to kind of make sense for how to implement RAG using all these capabilities. What's interesting is this technology DiskANN. So this is Disk Accelerated Nearest Neighbor algorithm that Microsoft apparently uses for anything that's living into the Office 365 Teams, graph databases. So it's a super sophisticated technology that Microsoft Research had developed, and Microsoft actually uses for quite a bit of time on a lot of their internal products. So now they're making this DiskANN technology available in Cosmos DB. And what's cool about it, I'm not going to bore you with all of the super sciencey, data sciencey stuff, but basically the idea is it's extremely fast and it's extremely robust. And with a combination of Azure Cosmos DB, it's actually very economical. So the combinations of those three things make it enterprise grade. And the other thing that we get is we actually get an ability to manage it. So here I created a Cosmos DB instance. And once you create that, you will need to learn a little bit of how to use it. If you have a relational database background, this is not super intuitive, but it's actually not that difficult. But in order to enable everything, once you have applied for the preview, you then go to features, and you want to enable this feature. It's called vector search for NoSQL AI preview. You will have to click on this, and then there may be a button here that says enroll, already enrolled. So there may be, this looks a little bit different from what it looks for you, but basically you just come here, click on enroll, and that will then provision that feature for you. And once you have that going, the only other two things that you need to remember about is you need to know this URI that will come in handy. I'll show you why this is important. And you will need to generate a key or read a key from this section. So in order for us to wire everything up in the RAG and use our Azure Cosmos DB, we need to have information for those two things. The other things that's interesting about Cosmos DB is this concept of containers and databases. So here I've created a knowledge base container where I will be hosting my knowledge base. We will look at this in more detail later, but just to give you a bit of a flavor of how to navigate through Cosmos DB if you have not seen it before. The next step is to then take a look into our Python Fabric notebook and go through this and see how everything works. So let's dig in. Let me make myself smaller so that I don't occupy quite as much room on your screen so you could see a little better what's going on. Okay, so the way RAG architecture is implemented in Fabric is we're using effectively two major components. We're using LangChain, and I will put this notebook, most of it's on our blog, so look for the link to our blog in the description of the video. But the first step is, and let me also make this a little bit bigger so you guys can see a little bit better. I know sometimes I forget to zoom in, so let's just do things this way. So here I install a bunch of LangChain components, and I also install Azure Cosmos, LangChain, some other components here, right? So this is the prerequisites. These are the prerequisites for me to be able to run my code. The next step, this is cutting up a little bit too much. Let me see if this is going to be better. Okay, let's just go with this. All right, so here, what do we do next? Well, we do need to be able to connect to our resources. I assume you already have created OpenAI component. So instead of, because my capacity size is not F64, it does not come in with OpenAI built in, I'm using a PaaS component that I set up in Portal, in Azure Portal. And so I connect to, I save the key in my key vault for the OpenAI. I also saved the key for the Cosmos DB. Again, that's in here in key section, okay? So now these two lines will get me keys, and then I need to set up all of the variables, all of the information necessary to instantiate my components. So in order for me to create all of the OpenAI objects, I need to give it a service name. I'm going to be using the ADA02 for my embeddings. So here we're using two different models. This model is used to ask questions. So in the diagram, the model that's answering question is this one. Okay, so this happens here. Okay, so this is the model that does that, and this model is the one that does the embeddings. So in our architecture, it's the model that takes the question and converts it into embeddings, and that's the question that, or rather, the question here comes in text, but this is the model that's bringing together a question with my documents, right? So this is happening in here. Okay, so that's why we have two different models. One is done to answer questions, and one is done for creating embeddings. Then I'm creating these environment variables. Now I struggle a little bit in Fabric to instantiate OpenAI objects. So when you create an OpenAI object, I will show you later, you could pass a bunch of parameters or you can read from the environment. I find it a little bit more reliable when it's creating objects from the environment variable. This seems to be a bug. So I found that unless I delete this environment variable, by the way, I never set it. So I think when you have a normal Fabric Spark notebook, that variable is already set up. So I just delete it explicitly to make sure that it's not set up, and that helps me. And that helps me with instantiation of all of the important objects. Okay. So then what I do is I do all of my imports, and now the fun begins. So the first thing that we do is we're using the LangChain's PDF loader object to help us read the documents from the folder. So in my original video, I used the document intelligence, which is a PaaS service in Azure. And I'm sure it's a very mature technology that allows you to do a bunch of things in bulk, and it's very sophisticated. However, if all you're trying to do is to read a bunch of PDF files, this seems to be working quite well, and it doesn't take very long. And then what happens, I wrote this function. What this function does, it just reads all of the files from my lakehouse. So in our example, I took a couple of PDF files and loaded them into a lakehouse. And then this function here just reads things from my lakehouse, and the lakehouse is specified in this variable here. So I just create a lakehouse, and in this prohibits folder, I put a bunch of documents. And then what I do is I read those documents using this function. And once this function runs, I just want to print out all of the documents just to make sure that all of those documents got picked up and processed. So this variable documents will then display which documents have been read. And you can see that when this runs, it says, okay, I read document name ChatGPT information, and I read document name prohibits company brief. So I will be using these two documents to ask questions. Now I'm going to display my documents. Here are the two documents, and I can click, and I can see the content of those two documents. So what I've done so far is I've taken those documents and I've processed them in a Word way, right? So those are binary documents. So what my function did, it extracted all of these words and effectively allowed me now to work with them. Now that I have those documents, the next thing is what I'm doing here is I'm creating indexing policies. So what this does, this is very much specific to Cosmos DB. So again, if you're coming from the traditional relational database, you're probably looking at this and saying, hey, this is making no sense to me. And it probably deserves its own video on how to work with Cosmos DB, why Cosmos DB, NoSQL versus relational, indexing, document management, partitioning. There's so much. If you're coming into this Cosmos DB new, there's so much to learn. Basically, all I would say is for now, you just have to create these two variables, indexing policy and embedding policy, and those things get passed into the call when I'm creating my vector database. So what's interesting here is cosine is the way we're going to be doing the similarity search. Again, this is whole data science conversation of why cosine versus others. For now, let's just think about that. What we're trying to do is when we ask a question, we're trying to find the relevant documents or relevant information that's close to what we're asking, and there's different ways to do this. How close it is, that's what distance is, and Cosine is one of the ways we can generate that distance or calculate it. And then in our case, we're using this DiskANN embedding, right? The super powerful enterprise grade vector index that allows us to do super powerful, cool, quick searches that are economical but also extremely powerful. So the next thing is we're gonna start creating our vector information, storing our documents. So our documents right now live in this variable called documents. And now our next task is to store them in our vector database. So what we need to do is we do a couple of more imports, and now we need to provide a couple of other parameters. So the first thing is what's my host and what's my key. So the host information, that's this piece here, this URI, okay? And then the Cosmos DB we had extracted using the Azure Key Vault. Now we're going to create a new object called Cosmos Client, and all that object does, all we need to do to create that is we need to pass a host and a key, and that's going to give us a Cosmos Client. Now we need to pass a couple more parameters. So in order for me to create that vector storage, it's going to ask me what's my database, what is my container, and container is like a table. It's going to ask me what is my partitioning key. Now again, NoSQL databases are quite unique. I'm not going to get too much into it, but they need that information. So, and then it needs these two additional variables. One is Cosmos container properties, and one is Cosmos database properties. So unless you provide those, and this is very important, your call to create a vector index will fail. The next one is I'm going to create another object that's going to create an Azure OpenAI embedding. So now what this object will allow me to do, so the Cosmos client will allow me to treat my Cosmos asset as a vector database, create new records and query them. And this object allows me to create my embeddings. So and what embeddings again is, it's going to take a text, something that I read in English, and it's going to convert it into that vector, a bunch of numbers that is a digital representation of my words. And we will take a look at what these embeddings look like. The next thing is we're going to create another object that's called a text splitter. So what this does, it's using a LangChain library. And what it does, it says, hey, when I'm going to give you a large body of text, split it into a bunch of chunks. In my case, I'm taking those chunks 4,000 characters long. And what happens sometimes is the way things are paginated, there may be an important paragraph that gets cut across multiple chunks. So what we're going to do is we're going to do this chunk overlap of 200 to make sure there is some information that's been split by this, that we have a bit of an overlap and we don't break that important information into chunks so that meaning is going to be lost. So this is arbitrary, and this is a bit of a science. So when you build RAG, these parameters actually matter quite a bit, and you will have to figure out and dial that in based on your specific situation. The next thing that we do is we take our documents and we split them in those chunks, 4,000 large with 200 overlap, and we store it in a splits object. And lastly, what we do is we create our function that says Azure Cosmos DB vector search from document, and we're passing all of this information into this vector search object. So that's this vector search object is the one that's ultimately going to be able to do all of the interaction with my vector database. So what do we need to pass into it? We pass our documents, which are splits. We'll look into those later. We pass our embeddings, okay, which is an object that does embeddings. We pass our Cosmos client, and then we say this is my database, this is my container. We're passing those policies, which are these two things here. And then we're passing the container and database properties, which are these two lines, okay? So in a database property, we just pass the database name, and then a partition key. In a container property, we pass a partition key. So once all of this is done, we can start asking our questions. So I say, hey, what is prohibits? So this is my question, and prohibits is something that's defined in one of those two documents. And what I want to do is I'm going to connect to my vector search object, which is this guy here. Okay, And I'm going to run a similarity search on that query. And then I'm going to print out my answers, and you see my answers come out as a bunch of embeddings, right? So here we see the relevant information, right? So this is what got extracted. So I'm saying what prohibits, and you see prohibits, prohibits, prohibits. So it basically went out and found like these chunks that talk about what prohibits is, and it stores them in answers. And it also found the embeddings, right? So you could see that for so it returns both text and embeddings. And embeddings look like these rows of these numbers, right? So when you say create embeddings, effectively what you do is you take this text and you convert it into these numbers. And that's what vector database searches. It searches in these numbers, and somehow it finds the information by meaning in text that's very reliable and works very well. So let's take a look at what it creates now in the Cosmos DB. So here we have our KB database, we have our knowledge base container, and within that you have our items. So these are my items. And then I could click on all of these items, and I can see that each item has ID, text, embeddings, and actually document name. So now what I'm going to do is I'm going to run a SQL query. So let's say I'm going to do select, and now you can see that it's seeing all these documents. Each chunk rather has an ID, it has text, and I'm going to try to remember what the document name column is. Let me find it. So now you can see that in my knowledge base, now I have a couple of documents. It's showing me the document name, right? It's giving me the text, and there's a, so you could basically use, so here I have select c.id, c.text, and c.document name from C, and that's giving me kind of what I've stored in my knowledge base. So what's cool about this is, and that's why I like this better than Chroma DB and even Azure AI Search, I kind of have a more or less familiar database tool. I can create my tables, so I can basically take my database knowledge, my data engineering knowledge, my data modeling knowledge, and I can marry it up with my Fabric knowledge and with Cosmos DB to create that knowledge base where I have my vectors and I have my, kind of the information, everything that I know about how to build databases, SQL skills. So I have a little bit more robust way of managing my knowledge base. The other cool thing about DiskANN is that I'm storing the vector information, the index information right next to my data. So I don't have to keep my tables in one database. I don't have to keep my vector information in another database. I kind of keep everything in one asset, and that makes it much more convenient. Now, there's still a bunch of questions on how do you manage information across multiple domains, how do you manage security, how do you keep information up to date. So there is a ton of stuff that we still need to double click on and figure out to really build an enterprise grade RAG and enterprise grade knowledge management and bring together the vector capabilities, Fabric capabilities, database capabilities, bring it all of that together. But I feel that with Cosmos DB and DiskANN, this is a really, really good start, so that now we have kind of the technology, the platform to build upon. So let's just keep going through our text. So now we're going to take a look at these answers. So I'm going to just look at the page content. So I'm just going to look at what it found and disregard the embeddings. So this is the text. And then finally, we're creating this message. We're now going to be creating a little chain in order for us to ask a question. So my question is, tell me what you know about prohibits. And then it's going to invoke the chain and what is prohibits. Sorry, I'm asking this message, but I don't really use anywhere. So then I say rec chain invoke, and my question really is, what is prohibits? And this is giving me this answer. Prohibits is a platform that connects individual employees with their company mission, values, and strategic objectives, and so forth. So what that is OpenAI taking my question and then taking that information that's stored in this chunk of text here, and then it's marrying it together, and then it's providing me with this answer. So now we have successfully implemented our RAG in Fabric, and we're now using Cosmos DB, Azure Cosmos DB with DiskANN in order to implement an enterprise RAG. Okay, what is next? As you can see, this is already a pretty long video because there's so much new information and so much technology packed in order to implement RAG in Microsoft Fabric using a more robust approach like Cosmos DB, DiskANN, but I still think it's worth it. So I took a little bit more time this time around to take a deeper dive, walk you through exactly what's going on, how we're thinking about this technology, how do we compare one with another, and hopefully give you some tools to figure out what makes more sense. So I will be creating a blog and posting this code on our blog, and blog will be in the description of the video. And now we're gonna just do a little bit philosophy and just let me reflect a little bit on what we did and what I have learned over the last couple of months looking at all this stuff, trying to implement these things in Fabric. And just quick summary if you guys have been following my journey on what I have learned and where my thoughts are thus far. So with every day that goes by, I become more and more impressed with the new world that all these technology open up for us. It's still not very clear as to where we're going and what the right set of ingredients will be, but it becomes more and more clear to me that what's coming is a complete transformation of the world we're living in. I'm learning more and more about the limitations of these LLM and Gen AI technologies, and I'm also learning more and more about the amazing use cases where they work really, really well. RAG is going to be a fundamental tool in the BI, data engineering, logic intelligence toolbox of the future, and I definitely recommend that every company and every person in this AI analytics space gets really smart around how that works, why we need it, what the limitations are, and which technologies come together, and how they may be a better or worse fit depending on your situation. So I am actually very impressed with Cosmos DB and DiskANN tandem or duo. Because what it allows me to do, the tools on top of it, it's a lot more mature than Chroma DB. It's a lot friendlier for somebody like me. If you have database background, data engineering background, then let's say AI search. So there is a lot of good things that for sure I could say about Cosmos DB, DiskANN. The concerns are specifically for Fabric use case is that we are still now splitting our architecture between two paradigms. We have our SaaS paradigm in Microsoft Fabric. We have our PaaS paradigm in Azure. So that means two sets of interface, two sets of deployment procedures, two security paradigms or more, right? So communications, a bunch of different teams will have to come together to make all of this work. And these are some of the negatives. So hopefully somehow that linkage between Cosmos DB and Fabric will become easier over time, interfaces will get better, and it'll become a little bit better from the management perspective. So we will see where these things are going. I'm super excited. Now, I would like to ask for you guys to provide with some feedback. Was this video too long? Am I getting too far deep into the weeds? Get too much into the code? Would you like to have like a shorter version and a longer version, which is a deep dive? So if you have any feedback on how to make this type of content friendlier for you, please share it in the description of this video. If you found this video to be useful and informative, we would really appreciate a like and a subscribe, and I will see you soon on the next one.